Hello guys, how are you? This is Hans Hawi once again. So in this video we'll be looking at effect of force on motion, and we have laid down the specific objectives from our syllabus. So these are the objectives that we are going to cover. By the end of this topic we should have covered all of them. You're expected to know them all. Okay, let's jump right in. So here we are. Effect of force on motion. So we are saying a force can, one, cause a moving object to come to rest. For instance, the simple one that you can be thinking of is probably when you are playing football. What you do is when a ball is kicked towards you, you might stop it. So it has been moving, you applied a force, it stopped, it came to rest. So that's it. Then change the direction of a moving object. Also, when you are playing football, or maybe when the ball is moving towards you, you can kick it so that it changes its direction, right? So that's one example. Then number 3, cause an object at rest to move. Cause an object at rest to move. For instance, a car, you can actually push a car at rest and then it moves, right? That's one example. You apply a force with your friends to move the car. Number 4, change the speed of an object. You can actually change the speed of an object by applying a force, right? So I'll ask you to think of examples where one can apply a force and the speed changes, the speed can increase or decrease, okay? Then here we are saying the unbalanced force acting on an object is responsible for changing the motion of an object. Okay, shortly we are going to have an illustration and a few examples to show what we mean by this, okay? Newton's laws of motion, we are going to look at 2 of them here. A body at rest could remain at rest, or if it is moving, it will continue to move with constant velocity unless an external force makes it to change its state of motion. So in essence, this means that for an object to move with constant speed in a straight line is as natural as for a book you leave on your desk to remain there until you remove it. So when you see an object moving and then after some time it stops, then there has to be an external force that caused it to stop. If the body was at rest and then it started moving, there has to be an external force that caused it to move because it was at rest. Or even an object to change its direction, there has to be an external force to cause it to change its direction, right? B, we are actually going to be looking at this Newton law of motion. B, the acceleration of an object is directly proportional to the resultant force acting on the object. Mathematically, this can be expressed as F is equal to ma, when F is the resultant force in newtons, right? M is its mass in kilograms. Then A is the acceleration in meters per second squared. So this is the equation that we are going to focus on right now, okay? Well, when we are using this equation in calculations, F is equal to ma, F is the resultant force, the unbalanced force, right? We can also determine the resultant force using the given forces. For instance, F is equal to F1 minus F2. What do we mean by that? Okay, here is a quick example. Supposing two forces are acting on this object, right? This is F1, this is F2. Say F2 is 50 Newton, F1 is 100 Newton, right? So the resultant force, the effective force, is the difference between these two, which is resultant force F1 minus F2. So this is 100 minus 50. Then what do we get? The answer is 50. So this is the resultant force. If we have something like this, say this is 250 newtons, and this is also 250 newton. The resultant force, once again, is F1 minus F2. So we have to label this one F1 and this one F2. So what is the resultant force? 250 minus 250. The resultant force is 0 Newton because the opposing force are equal. So this is the resultant force, right? And also we need to understand something here. We have two formulas actually. For most of our problems will require you to use either this one to find the resultant force or this one. So depending on the quantities that are given, right? So if you are given mass and acceleration, you're going to use them to calculate the resultant force. If you are given two opposing forces, okay, the forces can be more than two. Let me illustrate that. We can have a situation like this. Let me just make it more forces. So supposing this is 100 Newton and this is 50 Newton and this is, or what can we say, 75 Newton, this is 25 Newton. So we have to combine this to make it, 100 Newtons, right? We add 75 plus 25 to make 100 Newtons. Then in this direction we add 50 plus 150 to make it 150. So you might not want to draw this, but it makes your life easy. But at the end you have to add these 150 minus 70 minus 100. That's 100. So the resultant force will be 150 Newton minus this 100 Newton, which is 50 Newton. That's your resultant force F. Okay, so I want us now to look at an illustration to illustrate this so that we understand what we are talking about. Okay, so here is our illustration. We have a car here. For the first one, let's call this one A, example B, C, and D. I want us to choose here because A and C, the opposing forces are equal. So let's say in this case the direction of the car is this one. Motion, right? This is the motion, the direction of the car, and this one the same, but this is direction. Okay, but for this one A, because A, the forces are equal and we said it's moving to the right, for this one, let's say the car is at rest, so initially it is at rest. So talk about the forces in this case. Once again, this is the direction of our car. The motion is to the right. So let's start with A. What is happening at A? What is happening at A? So the two forces here are equal. The two forces are equal. Two forces are equal. So this is 500 Newton minus 500 Newton. Where am I getting this? This is F. Remember, F is equal to F1 minus F2. Right? So they cancel out. They cancel out. The resultant force will be 0 Newton. When the resultant force is 0 Newton, that means the acceleration will be 0 meters per second squared, because actually the acceleration is caused by the resultant force. It's caused by resultant force. So it's caused by the resultant force. In this case, then what you're going to have is, because the car was already moving to the right, it will move with constant velocity. The car will move with what? With constant velocity to the right, because it was already moving to the right. So B, let's look at B. What is happening at B? At B, we have opposing forces which are not equal, right? The opposing forces are not equal. So the resultant force will be F1 minus F2, which is equal to 4,000 minus 3,000. So F is 1,000 Newton. So we are going to have, we will have acceleration. We'll have acceleration because we have what? The resultant force. Because remember, the resultant force is responsible for causing what? Acceleration. Therefore, the car will accelerate. The car will accelerate to the right. Right. In this direction which it was directed to. Right? Then let's look at C. What is happening at C? The forces are equal. But the object was at rest. So even if you can apply 1 million newtons this side and 1 million newton this side, if the object was at rest, it will continue to rest because the forces were applied while it was at rest. But if it was moving, it was going to continue to move like at A. So in this case, what do we say? The forces cancel. They cancel out, just like at example A, that is 7,000 Newton minus 7,000. F is equal to 0 Newton. They cancel out. The resultant force is 0 newtons. Because the resultant force is 0, acceleration will also be 0. Will be 0. But in this case, there won't be any movement because initially it was at rest. Initially it was at rest. So there is no movement. So if the car is at rest and such forces are applied, the object will feel no force because any movement, because they are equal and they are opposing, right? Then let's look at the last one, D. In this case, we see that these forces in the opposite direction, they are greater than the what? The forward forces. So what do we expect? So this is what normally the opposing forces are friction. It could be friction due to the tires and the road surface, and also the air resistance, right? So friction is greater than the forward force or the driving force, right? So F is equal to, so this is, in this case, we can say F1 here and F2 here. F1 minus F2, that is, they combine to make 2000 Newton, and this is 1500 Newton. So the resultant force is 500 Newtons directed backwards, right? So there will be a what? A negative acceleration. Usually it's called the car will decelerate, right? Decelerate. So this is acceleration, right? So this is just deceleration. So the car will eventually come to rest. Okay, that's it about this illustration. So in the next video, we'll be looking at examples. We'll solve problems related to the effects of force on motion. Thank you.